I welcome you back. I welcome you back to this tutorial on empirical formula. On empirical formula, we had covered item 17, so we continue with item 18. Item 18 says that Anzimuke wanted to produce a gas that can help him in boiling and cooking his water and meals, but doesn't know how the gas looks like and how to do it. He was advised that he can react. Listen, he can react 74. He can react 74.9% by mass. Can react 74.9% by mass of element X. 74% by mass of element X, and the remaining percentage to be that of element Y. So we have 74.96 Y. X, sorry. 74, it is here. 74.96% by mass of X. So the remaining percentage is that of Y. To form 1 mole of the product that has vapor density. Now, this is a new term. Vapor density 8.05. Anzimuke still wanted to know more about the compound formed and approached one of the greatest chemists around for further assistance. The chemists told him that the compound is written as this. Now, this is how the compound is written, where X and Y are not, listen, X and Y are not actual symbols of elements. The chemist also informed him that X belongs to group 1, period 2. Now here they have to give you the periodic table. X belongs to group 1, period 2. And Y belongs to group 1 and period 1 of the periodic table as shown below. This is the periodic table. Now, I take you back again. What have they said? They have said X belongs to group 4 and period 2. Group 4, period 2. Group 4, period 2. These vertical columns from senior 2 chemistry, the vertical columns are the ones that we call the groups. Vertical columns, they are the groups. Then the horizontal rows are the periods. So the vertical columns are the groups. This is group 1. Group 2, group 3, group 4. Hope you are seeing my cursor. This is group 1, group 2, group 3, group 4. This is group 4 where we have carbon, silicon. This is group 4. Then this is period 1, period 2 is this one. So the element is found in group 4 here and period 2. So you correspond group 4 and period 2. That is element carbon. Element carbon with atomic number. Hope you are seeing atomic number down here. It is 12. No, atomic mass, sorry. Atomic mass is the largest, is 12. Atomic mass is 12. Atomic number is 6. But in determining empirical formula for us, we are interested in atomic mass, which is 12. So group 4 is this. Period 2, this is period 1. Period 2 is this one. So you correspond group 4 and period 2, you get element carbon with atomic mass 12. Then what next? Then Y belongs to group 1, period 1. Group 1, period 1. Group 1 is this first vertical column. Group 4 was this fourth column. Now group 1 is the first vertical column here where we have hydrogen. And the period 1 error is still this first horizontal row. So the element is hydrogen. Hydrogen with atomic mass 1. The atomic mass 1. So now we know what X and Y are. Yeah, but we may not use them in the calculation. We have just known that they are these ones. Help Anzimuke to know the value of N. So determine the value of N, of course, we need to determine the formula of this thing. Once we know the formula of this thing, then N can be evaluated. Hence, and help him to know the molecular mass of the compound formed. Yeah, molecular mass of the compound formed. So we are going to proceed with our calculation. We are on page. This is page. My response 1, 2, 88. Response 1 to 88. So here it is. So a percentage of Y, recall that they only give us percentage of X as 74.96%. So we determine percentage of hydrogen. We get total percentage, which is 100 minus that of X, and this gives 25.04%. Then the elements present are two. We have X and Y. Those are the elements present. Then we substitute composition. That of X is 74.96. That of Y is 25.04. Next, I determine number of moles. To determine number of moles, we divide the compositions by the atomic masses. X, we have seen that it is carbon. So we divide by 12. Atomic mass from the periodic table, atomic mass has been 12. Then Y, hydrogen atomic mass has been 1. Then we obtain these as our moles. So next we determine the simplest mole ratio. Determine the simplest mole ratio, you divide by the smallest of these two. And the smallest is 6.247. That is the smallest, 6.247. So we divide both of them by 6.247. And what do we obtain? We obtain 1 to 4. Implying that empirical formula is XY4. Now this is our empirical formula. Next, we determine the molecular formula. The molecular formula. Because now remember, empirical formula is the simplest formula. It is not the actual. Molecular is the actual from what I explained earlier. So we need to determine the actual, then determine the value of N. So the actual molecular formula, we need molecular mass. So to determine molecular mass, which information has been given in this question? This item has provided us with the following information. The item says that take note of this. 1 mole, it is here on line 2. 1 mole of the product has a vapor density of 8.05. Has a vapor density. Now we have vapor density. What did I say on vapor density? It is also here. This is the information on vapor density. From what I said earlier on, that note, given vapor density, how do we treat vapor density? Relative molecular mass is 2 times vapor density. So to get relative molecular mass, we multiply vapor density times 2. So vapor density times 2 gives relative molecular mass. This does not change. Then I go back to my item. Vapor density is 8.05 and relative molecular mass is 2 times vapor density. So we have the following. Going back to my item, we shall have relative molecular mass is equal to 2 times vapor density, and this gives 2 times 8.05, which is 16.1. So my relative molecular mass is 16.1. Then I substitute in empirical formula times N equals molecular mass. The empirical formula is XY4 times N equals 16.1. Now we have seen that X is carbon and it is 12. Capital Y is hydrogen and it is 1. Therefore, of them times 4 equals 16.1. So summing this up, we obtain 16 times N equals 16.1. 16.1. And dividing both sides by 16, we obtain the value of N as 1. So we substitute back our value of N. So substituting N equals 1 back where we have empirical formula times N, we obtain this as our molecular formula. Now this is the molecular formula. Therefore, we can conclude by saying that N is 4 because N was on Y. Yeah, N was on Y, so N is 4. N is 4, and that marks the end of item 18. Item 18. Allow me first stop this here.